This is chapter 6.5. In this video lesson, we're going to go over exercises 1 through 6, the odd numbers anyway. This has to do with graphing polar equations. And basically, we're just going to briefly get into it here with a couple video lessons. In exercise 1, to complete the table for the polar equation, and B, plot the corresponding points. And so if we look at the equation, r equals 3 cosine 2 theta, and we have 0. Well, if we have for theta equals 0, we have r is equal to 3 cosine 2 times 0. And that's going to be the cosine of 0, cosine of the angle 0 is equal to 1. So in this case we have r equals 3 times 1, which equals 3. So input for theta of 0, output of radius of 3. And now for theta equals pi over 2, pi over 4, we have r is equal to 3 cosine 2 times pi over 4, which equals 3 cosine. We have 2 times pi over 4 is pi over 2. Well, cosine of pi over 2 is 0, so we're going to have r is equal to 3 times 0 equals 0. So for pi over 4 we have 0. Then we have this pattern for theta is equal to pi over 4, which should be pi over 2. We have r is equal to 3 cosine 2 times pi over 2. Well, 2 times pi over 2 equals pi, so we have 3 cosine pi. Well, cosine pi is -1, so r is equal to 3 times -1, which equals -3. So there's -3 here. And for 3 pi over 4, if we take 2 times 3 pi over 4, we have 3 pi over 2. Well, the cosine of 3 pi over 2 is 0, and 3 times 0 is 0. So we're having a pattern here, aren't we? Well, here for pi, if we have 2 times pi, well, that's 2 pi, and the cosine of 2 pi is the same as cosine of 0, which is 1, so we have 3 to 5 pi over 4, 2 times 5 pi over 4. This should continue with our pattern. It's going to be the same as 5 pi over 2. Now realize that we've gone around, so 5 pi over 2 is going to be coming back up here, and we're going to have 0 for 2 times 3 pi over 2. We're going to have 3 pi. And the cosine of 3 pi is over here once around plus another pi is going to be -3. And for 7 pi over 4, that's going to be 0. And so now we have everything we need to graph. And we're going to go here. And we're going to have 0 here. At the top, we're going to have pi over 2. At the far left, we're going to have pi. And then at the bottom, 3 pi over 2. And then 2 pi. And then we have at the top here 5 pi over 2, and so on, and then 3 pi. Anyway, we go over here, and we have theta 0. We have radius of 3, so 1, 2, 1, 2, 3. There we go. Sure these points are distinctive. For pi over 4, we're right here at 0 at the origin. I'll make these in red and make these a little more visible. And then for pi over 2, we have -3, so we go to pi over 2. Now, -3 is the other direction. Normally we come up here, but for -3 we had to come down. We got to go the other direction. So hope you remember that from that last section, 6.4. And then for 3 pi over 4, well, 3 pi over 4 is up here, and we're going to have 0, which comes right back here again. For pi, we're going to have 3, so here's pi at the very left. We have 1, 2, 3. For 5 pi over 4, 5 pi over 4 is down here. We have 0 again. For 3 pi over 2, which is down here, we have -3, so we got to go, -3 is the opposite direction, so we come up here. And then 7 pi over 4 over here in middle quadrant 4 is 0. So these are the points, and this one down here is repeated 4 times. So this is for pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And these other 4 points are for the remaining. So anyway, that's problem number 1. Problem number 2, very similar. Just go ahead and fill out the table, then plot in your points. I think it's some kind of a triangular sort of arrangement there. Okay, in exercise 3 through 6, draw a graph of the rose curve. State the smallest theta interval between 0 and k that will produce a complete graph. And so I'm going to go ahead and we can draw a table. What I'm going to do is just go to our graphic calculator and have our graphic calculator help us out. Again, we're going to have over here 0, up the top here, pi over 2. We're going to have pi over here at the far left, and at the bottom we have 3 pi over 2. And if we, in degrees, these would be 0 degrees at the right, 90 degrees at the top, 180 degrees at the left, and 270 degrees at the bottom. So we go to our graphing calculator, and here it is. We go to menu, and we go to 3, graph entry edit, and then we have option 5, polar. And for polar, our equation is going to be r equals 3 times sine, and we have 3 theta. So 3, and we go to the pi button down here, theta, and then we just graph and see what this looks like. So what we have is 3 petal rows, and the thing about it is, if you have an odd argument here, like sine 3 theta, and it's an odd number, that's going to be the number of petals in the rows. And so graphing this out, what this is going to look like on the polar coordinate is right Let me get some red. It's right here at okay, quadrant right here. We can do a trace. And then you trace 5, graph trace. Okay, right here at 0. Okay, -1, we have the radius, 0.5 radius. So it's going to be this kind of pattern here. So right here we have a radius of about 3, so it's going to be in this sort of arrangement. The one we know for sure is the one at the very bottom. We have a radius of 3. Okay, that's going to be one of the petals. And then every 120 degrees apart. So let's see, it's going to be 90, 120. We're going to be 3 up here. And then over here, on the other direction, it'll be 3 up like this. And so the graph is going to look like this. Okay. Roughly. And really, the k is going to be equal to pi, which means that pi makes a complete circuit of this. So really, that's what we're going to have in this exercise, pretty roughly drawn graph. Next, on number problem 5, well, here we have the argument equals is 2 theta, and we're going to have, for even numbers, we're going to have double 2, so we're going to have a rose with 4 petals. And what that means is that to get our 4 petals, we're going to have to go 2 pi. But going back to our calculator, we'll go Control I, add graph, 3, graph entry edit, 5 polar, and for this we're going to put down 3 cosine 2 theta, so 3 cosine 2 theta. And then get our theta. There we go. Graph. So we're going to get 4 petals, again twice this even number 2, the argument of 2 theta. And the petals are going to be maximum 3 in length. So we go here, and it'll look like this. 3. And rather. So the petals are going to look like this. First petal wasn't so bad. There we go. There's our second petal up on top here. Our third petal over here to the left. And our 4th petal down here. And for this one, our k is going to be equal to 2 pi. We're going to need 2 pi to make a complete, so anyway, that's going to be the extent of our video lesson here, and good luck on your even number problems, and I thank you for viewing.